Alright, well let's just jump right into this video. My first 3D printing video was basically about how to improve your first layer. The first layer is the foundation to your print. If it doesn't stick to the bed, it'll come loose. The print head will knock it off, start dragging it around. That's where you get a wad of spaghetti in your printer. Then it can cause damage. It can jam the print head to the side of the printer or run into it. It's just a mess. It can also cause warping. So your first layer goes down, you start building your print up, but as the layer height goes up, it gets further away. The print filament coming out is, let's say, 230 degrees. The bed is 60 degrees. So in between there you have a temperature gradient. And if you paid attention at all, like in high school physics or anything, you know that heat, most materials expand. When they cool off, they contract. So that heating and contracting can cause a corner, especially on something with a sharp angle, a square, cause that to lift and warp, which can cause issues when you pull the item off for fitment, for visual appearance. If you don't have good first layer adhesion, when you pull it off and flip it over, you can have bad spots on the bed. So my first video, we concentrated on getting that first layer right on PLA. Yesterday I wanted to print some items in PETG and spent most of the day pulling my hair out.
You're getting a bargain. I ain't got no hair no more.
Found out something very, very interesting, which I wanted to share with everybody, and hopefully it can help you out, help you avoid the similar kind of problem in print failure. So let's look at what we have. So as you saw in my previous video, I tuned the Z offset, the layer height, and it got good prints on PLA. So I thought, hey, this is great. I don't know if you can see, since I use a smooth bed, I purchased, you can kind of see the holographic reflection in this. So this is very smooth. It stuck pretty good until it didn't. And then when it didn't, it started doing this. It just prints spaghetti because this is being moved around. It's just extruding filament into space, and it just drags this around and actually got this pinned up between the print head and the side of the printer, knocked the print head cover off. Luckily, about that time I saw it and stopped it. So just a huge mess, but like I said, it knocked the print head cover off, and that's actually what this is, because in the past that has happened, and it's broke a couple of the little clips on my Cobra S1 that hold the print head cover on. So I said, okay, I have read before that you could possibly need a little bit different Z offset on different materials, because some like to be squished more into the bed on the first layer than others, or squished together for print strength. So I think I did a first layer test and got this. So if you get a first layer test that looks like this, the lines aren't sticking together, it means your print head is too high, your Z offset is too much in the positive value. Negative is down toward the build plate, positive is away from the build plate. So I said, oh, okay, no big deal. Let's adjust the Z offset more negative. So we adjusted the Z offset more negative. We got this, which is much better, but I was kind of confused because in these places it looks like the filament is balled up, like it's too tight, like the Z offset's too low, yet each individual filament line is not sticking together, so that tells me it's still too high. And so then I printed this one. Which, hey, it started out great, and I'm like, hey, I've got it. I'm gonna let it run just a little bit longer, but that's perfect. But then it got over here almost in the exact same place as this one. We got issues there, issues in this spot. You can see issues in that spot. So what in the world is going on? Oh, I have a dirty build plate. I've got fingerprints, the oil on my fingers on the build plate. So I cleaned it off, still got this. So this one's a little bit better. Doesn't have all of these, doesn't have a spot right there. Does still have a spot there, does still have a spot there. So what's going on? So isopropyl alcohol, which I had to come back and check mine, and mine shouldn't be having an issue. This one is 99%, so I didn't think I'd have an issue. But typically your 93, 91, anything lower than that is going to leave a white film on whatever you're cleaning. Used to work on big industrial copiers, and that was a problem. If I can see a little bit of film or haze on the build plate. Now I can't take it out because I'm printing something right now, but I have a smooth holographic effect build plate, which I have read that PETG is very hard to stick to those, because I believe, and I can just tell by the feel when I print something in PLA and PETG that PETG is just a little bit smoother. And so, so your build plate, we'll pretend that this is the build plate. Even a smooth one, if you look at a microscope, it's got microscopic bumps and valleys and crevices and scratches. So your filament, when it goes down, can lock in. That's how it locks in. So your textured build plates, it has a better chance of locking in. I haven't really had any issues lately with the PLA sticking to the smooth build plate, but obviously the PETG was having some issues, which I finally decided wasn't a layer height issue. It's actually the layer lifting. It's not sticking to the heated build plate. So what I went and got was your good old Windex, because it's an unbeatable streak-free shine. I don't think you'd want to use I don't know if they even make it anymore. I'm sure they do ammonia glass cleaner, but an ammonia-free glass cleaner, I think is what you want. This is all I did from the last one you saw to this. Well, it's like this. The only difference between these two is this was cleaned, the build plate was cleaned with alcohol. This was cleaned with Windex. No other difference. There is one slight issue going on right there, but if you've got a Anycubic Cobra S1, you know that's nothing. This looks like a sheet of paper. 99% of it is, I would dare to say, it's perfect. There's a few discolorations, which something's going on there. 99%, that is perfect. Typically not building something 250 by 250. This also, if you run one of these, it does two things. If you have a textured build plate and have some PLA or PETG stuck to it, print a first layer test, which you go into Anycubic slicer, just right click on an empty build plate, add a cube. I think it'll say add shapes, add a cube, and then go resize your cube to 250 by 250 by 0.2. Use the 0.2 layer height preset, because you're going to print one layer of filament. And with the same type, if you put PLA over PLA, you've got something stuck to your bed you can't get off, print one of these. And you could even, if it's just a spot, just print this smaller, but it's probably easier to print the whole thing. This will clean the bed off. The PLA will stick to the PLA, PETG will stick to PETG. And you can clean your bed plate. You can't do PLA to PETG, they don't stick together. That is the only difference. Windex, alcohol. You may want to use both of them. There may be some oils or grease or whatever on your hands or dirt that the Windex doesn't take off. The isopropyl alcohol will take off, but I would finish by wiping your build plate down. If it's a smooth one with Windex, I don't think a textured build plate would be nearly as much trouble with PETG. I know on my old Creality 5S1, I would typically use a glue stick, coat the area that I was going to print or the entire build plate with just a light coating of a glue stick. That would, number one, help the PETG stick, but also make it a little bit easier to release, because it typically will kind of dig in and bite to a textured build plate and usually holds really well. But I hope you learned something here. Sometimes the obvious answer is not obvious. Like I said, I thought that this still was something going on with the bed leveling, the layer height. One thing to touch on bed leveling. People are always like, "Oh, my bed leveling is 0.2. It's 0.25 millimeters off." You know that a human hair is almost 0.1 millimeters. So if your bed mesh is down under half a millimeter, 0.5, you're getting to the point where you're almost literally splitting hairs. If you install Ringcall's firmware and actually look at your bed level and you say, "Oh, it's 0.25 millimeters highest to lowest, it's horrible." No, I mean, that's just basically 2.5 to 3 human hairs. So you're literally splitting hairs. It's not the bed level. More than likely, it's temperature, layer thickness, Z offset, or bed cleanliness issue. Because I think a lot of my issues that I thought I resolved by adjusting my Z offset, which was off. It was off on this, it was off on PLA, but were actually because the build sheet could be cleaner. Cleanliness is next to a good first layer. And if you don't have a first good layer, you're going to have failed prints. You're going to post on Facebook. You're going to ask questions. You're going to say this printer is a piece of crap. I need to get something else. Clean your bed with alcohol, then clean it with Windex, non-ammonia, or some kind of really good quality glass cleaner that doesn't have ammonia in it. I don't know what ammonia would do to the build plate, but let's not bring that in. Let's just use non-ammonia glass cleaner. Clean our build plate. Run a first layer test. If you have this, you're good to go. If your layers don't stick together, your Z offset is too high, lower it, make it more negative, but be careful, don't go crazy. If you go too far negative, you can ram your nozzle into your bed and damage it. Ask me how I know. So, unfortunately, sometimes this is not a quick fix, not a quick process. Print a 1-layer test, peel it off your build sheet, identify what's going on. Is your build sheet dirty? Is your layer or is your Z offset too high or too low? Go into your printer profile, Anycubic slicer next. Raise or lower your Z offset just a little bit. I usually raise an offset in 0.02. I make changes 0.02 millimeters at a time, but make baby steps. You may think that's not very much, but it is. It is enough to make a difference. And so now I have a printer profile in an Anycubic slicer for PETG and one for PLA. And some people may say that's just too complicated, but if you want to have success, you're printing different materials that are made out of different chemicals that have different properties, both chemical, heat, adhesion. There's not going to be, one size fits all, unfortunately. If you don't get a first layer print that looks 90% like this, then you need to go back to the drawing board, figure out what your issue is, and fix it, because if you have first layers that look like this, then your prints are going to look like this, and then you're going to say, my printer sucks. But the printer can only print a good object, a good print, when it has a good foundation. I hope this has helped some people out there. I know that there's a lot of people frustrated, and it's not just with Anycubic S1 or Cobra 3 Max. Everybody says that Bamboo Lab is the bee's knees, but if you look on Facebook in the Facebook groups, there's as many people in the Bamboo Labs Facebook groups complaining and showing pictures of what I showed earlier of a print just wadded up with spaghetti that it didn't stick to the bed plate. So I think that those people would benefit from this as well. Clean the build plate, clean it with Windex, run first layer test prints to make sure they're right, and if they're not, figure out what the problem is. Is it a dirty build plate? Is it the temperature of the build plate? Is it the speed? Because as I mentioned in my first video, I run, and you can go into your filament profile and the printer profile and change these things. I run the first layer on the build plate. The build plate itself is 5 to 10 degrees hotter than the rest of the print, and the first layer print, the filament temperature, is 5 to 10 degrees hotter than the rest of the print. That seems to help the first layer adhere. I also go into the printer and slow the first layer way down. I think I looked at changing the first layer speed on one of these from like 50 millimeters a second to 30 millimeters per second, and because we're only doing one layer, it only added, I think, like 4 minutes to the print, 5 minutes to the print. And if it made the difference between this and this, that 4 minutes is worth it. The first layer looks like this, and it comes off 18 hours into your print. It detaches in the print bed. Well, now you've got a big ball of useless melted plastic to throw in the trash. Thanks for watching. Let me know if this is helpful. If you have any other ideas or tips or tricks, please leave them in the comments below and let us all know. Thanks a lot.